Alright guys, welcome to lesson 3. Today we're going to talk about going back to absolute value functions. We talked about how to solve absolute value equations in lesson 1. Then lesson 2 we took a little sidetrack and we talked about transformations. We're going to use that knowledge about transformations today to help us with graphing absolute value functions. So by the end of the day, hopefully you guys will be able to graph some absolute value functions. All right, so an absolute value function, last night on your homework, I gave you guys a question that looked like this. Gave you guys a table and asked you to complete the table. I think we plugged in some numbers like -3, -2, -1, 0, 1, 2, and 3. If you plug in any number for your function here, when you plug it in, the absolute value is going to keep the number the same. It's just going to change it to a positive. So it becomes 3, 2, 1, 0, 1, 2, and 3. And then if you graph these ordered pairs, like -3, 3, -2, 2, -1, 1, 0, 0. You keep doing that with all the other points that are on there. You get this V shape, which we kind of hinted at last class, that absolute value functions have that V shape. Today, we're going to be graphing absolute value functions, and most of them the equations are going to look something like this. You're going to have a number in the front, you're going to have a number being either added or subtracted here, and then you're going to have a number being either added or subtracted here. Okay? All of these are basically just going to be transformations of this one basic absolute value function graph that we have here, the V that's centered in the middle of the graph. These are just going to be transformations of it. Okay, and so what we learned yesterday is that this number here shifts your graph to the right and up. Okay, so now usually your the absolute value function's vertex is right in the middle here at 0, 0. But if you're going to shift it to the left or right, h units, and then shift it up or down, k units, say up here, now your vertex becomes whatever the h and k were, because it started at 0, so however far you go, that's what it's going to be. So basically what we can think of then is the fact that these numbers here and here, the h and the k, if you put those together as a point, they make up your vertex. But I want you guys to notice something. The h will be an opposite sign. Okay? Up here it says -h, but I put h. In the same way, if this was a positive h, then I would put negative down here. So this sign is the opposite, but that's not true for the k. For the k, it's not opposite, it stays the same sign. Okay? So those two numbers put together are going to make up your vertex. The other thing that we talked about was the a. Now the a stretched it. So, you know, if your vertex, I'm having trouble here with my words. If your V shape looks like this, and you multiplied it by a number greater than 1, it's going to stretch it vertically, right? Well, another way you could think of it is it changes the slope. So like, for instance, this slope is over and up. Well, now it's, for this new graph here, this more steep one, it goes over the same amount, but it goes way up further higher, right? So it changes the slope of the line. So how we're going to treat the vertical stretches and compressions then is we're going to treat them like a slope. It's our rise and run. But what's interesting though about absolute value functions is that you have your starting point, right? And then you have your rise and run. But we know they have a V shape, so we're going to rise, but when we run, we go both ways. So we get a V shape. So we go up, and then we go right and put a dot, and we go left and put another dot. So you get this nice V shape. Okay? So there's our process that we're going to go through for graphing. Just plot your vertex, rise and run in both directions, and get 2 points after your vertex. Connect them, and you have your little V shape. So that's how we're going to be graphing these today. Just so you guys know, these are just shortcuts for graphing these things. technically with any function, it never matters. You can always graph them in a very basic way. You don't have to memorize steps necessarily. You could always just graph it in the following way. You could just plug in numbers for x and keep doing that and get a whole bunch of points. And after you get a whole bunch of points, just connect the dots and you graph it. That works for any function you can think of. But the downside is sometimes it takes too long to do that. And the other downside is if you don't pick the right points, you might not see the shape of the graph correctly when you try to connect the dots. So these little shortcuts that I'm giving you guys for graphing are ways to make sure that you get it right, and it's usually faster anyway. So let's go ahead and begin here. Let's do number 1. All right, so it says graph each absolute value function below. All right. So let's go ahead and start by making a graph. The first thing we need to do is we need to identify our vertex. V with some right up here. This number and this number are what make up my vertex, but we have to remember for this one here, we changed the sign. So this says -3, but that's actually going to become a +3 when I write my vertex. And then the other one is going to be a 1. We don't change the sign of that one. So the vertex of this absolute value function is going to be at 3, 1 over 3 up 1. So I'm just going to put a dot there to represent my vertex. Okay. The next thing we're going to do is we're going to use the slope, the 2/3 there. What this means is we're going to go up 2 and over 3, but we're also going to go left 3. So we go up 2, and then we go right 3 and left 3, and we put a dot in both spots, okay? So here we go. Let's do that. So starting from my vertex, right there, I'm going to go up 2 and right 3, and then I'm going to go up 2 and left 3. Okay? So starting from my vertex, I went up 2, right 3, and then I went up 2, left 3. And that resulted in the other 2 dots up above there that you see. Once you have your 3 dots, your vertex, and your 2 points that you got from your slope, you go ahead and just connect the dots, and you've got your graph. But now that's all that you need to know for today. So I'm about ready to give you some more information. So if that's not too overwhelming to you, then pay attention. If it isn't, then you can just kind of ignore me for now if you're feeling overwhelmed. But what did we talk about yesterday, right? We talked about, or not yesterday, but last lesson. We talked about transformations, right? What does it mean when you subtract 3? Well, that's a shift to the right. And from our homework, we know that f of x equals the absolute value of x looks something like this, right? Well, as you guys can see, the green graph has been shifted 3 spaces to the right. What does +1 outside the parentheses do? That shifts it up. So you guys see how the green graph is hovering 1 space above the pink line? It got shifted up. And what does a 2/3 outside the parentheses do when you multiply it? Well, that would be a vertical compression. And so for that reason, it looks stout. It looks flatter because it got vertically smashed or vertically compressed. So it's the same function as the original one, just has those 3 transformations, and that's why it looks like that. So I just wanted to connect what we learned last class to this lesson. But you can actually get away with not doing that, just be perfectly fine by following the steps I'm giving you. So let's go ahead and do another one. So step 1 to graph is to plot your vertex. So let's do that first. What is the vertex? Think for a moment for yourself. What do you think the vertex would be? Okay, so it's this number and this number, but we just have to remember that we want to change the sign of the 1. So it's actually going to be -1, -3. So we're going to go left 1 and down 3. Okay? So that is the vertex. Now we're going to apply the slope. Now since my slope is a -2, since it's negative, we're going to go down 2. And since there's no denominator, you could think of that as a 1. So that means we're going to go right and left 1 space. So starting from my vertex, I'm going to go down 2 spaces and right 1 to put a dot. And then I'm going to go down 2 spaces from the vertex and left 1 and put a dot. And then we go ahead and connect those with and there's my graph. And just like we learned yesterday, this graph should make sense to us because, first of all, it has been reflected upside down. It's stretched vertically a little bit, so it looks a little skinnier than normal. It's shifted to the left from the center, and it's shifted down from the center. So all those transformations make sense based on our picture there. All right, let's go ahead and take a look at number 3 there. Number 3 is an example of what to do if you're ever missing any numbers. So on number 1, I would call that like a basic example. Number 2 was what happens when there's a negative in front. The main thing I want you guys to pay attention to there is that means it goes downwards. So you might want to make a note of that. Now on number 3, though, we're missing numbers. Okay, so what about when you're missing numbers? And I'll write you a little note here at the top. If missing the following things, so if you're missing the A value, that means it equals 1. If you're missing the H or the K, that means they equal 0. Okay? So what do I mean by A, H, and K? Remember the formula I gave you at the beginning of class today. So if you're missing the A, if there's nothing in front of the absolute value bars, then you can assume it's a 1. If you're missing the H or the K, then you can assume they're a 0. Now, why is that? Well, it's because this is multiplying, right? So if you don't have a number here, that's like there's nothing there, right? But in other words, what could you put here? What could you multiply the absolute value of x by so that it doesn't change? And the answer is 1. You would multiply it by 1, so it's the same thing. So that's why it's okay to put a 1 there. Whereas there's nothing in the parentheses, but it should be plus or minus something, right? So what would go here so that when I put it there, if I subtract it, I still just get x, and the answer is 0. So it's the reason why the A is equal to 1 when it's missing is because it's a multiplier. And the reason why the H and the K are 0 when they're missing is because they are being added or subtracted. So, but anyway, so that's all I wanted to point out there. So what I'm going to do first on number 3 is I'm going to start by rewriting it a little bit. Now you don't have to do this, but just for teaching purposes, I will. And when I rewrite it, what I'm going to do is I'm going to put the missing numbers in. So you'll notice that there's nothing in front of the absolute value bars, so I'm missing my A. So that means it's a 1. You'll also notice that there's nothing inside the absolute value bars being added or subtracted from the x. So that means my H is missing, and when H is missing, that means it's a 0. Now you can put plus 0 or minus 0. It really doesn't matter because it doesn't matter if you add or subtract 0, it's the same thing. Now my K value is the number outside the bars there being subtracted, which we do have. It's a 2, so I'm just going to put that there. All I did was I rewrote this like this. That way it's a little bit more visual for me to teach you how to graph it now. So now we're going to do our vertex. And when you do the vertex, you take these 2 numbers here. And don't forget to change the sign of this one, but in this case it doesn't matter because it's 0. So there's my vertex. And my slope is 1. So I'm going to go up 1 and over 1. So here we go. Vertex is 0, negative 2. I'm going to go up 1 and over 1 to the right, and then up 1 and over 1 to the left. And now I've got my graph. Okay, so number 1 was just to give you the basic idea. Number 2 is to show you what happens when it's negative. That means you go down when you do your slope. Number 3 is to show you guys what to do when you're missing numbers. So is number 4. I just chose to make us be missing some other numbers. And also I put another negative in there. So let's see how this one works out. So if I wanted to rewrite this, what numbers are we missing from this expression? Well, you may notice that we don't have the number in the front. But like I told you, when that happens, it means that A equals 1, right? And we also don't have the number over here. That's our k value. When k is missing, that's 0. So if I were to rewrite this, which once again you don't have to do, but I'm going to, it would look like this. Okay. Now that I've done that, I can see what my vertex is. My vertex is this number and this number, but don't forget to do the opposite sign of the 2. It's going to be 2, 0. And my slope is a -1, which don't forget, that means we go down when we go left and right. Right? So here we go. 2, 0 is here. And I'm going to go down 1 and then left and right 1 because the denominator is also 1. So down 1, right 1, down 1, left 1. And there you go. That's graphing absolute value functions. And if you guys want to pause the video here, please. Try to graph all these, and then whenever you are done, I will put the answers up for you. All right, so here are the solutions. This is number 1 here. For number 1, the vertex was 0, -5, and the slope was 3/2. So up 3 over 2 to the left and right. So you got your V shape there. Take a look at number 2. Your number 2 should have looked something like this. The vertex for number 2 should have been 3, 1. So that's right there. And the slope is a -1/2. So that means you're going to go down 1 over 2 to the left and right. Let's go ahead and look at number 3. Number 3 should have looked something like this. We had some missing numbers on number 3 here. We didn't have the A and we didn't have the K, which means our vertex should have come out to be -2, 0. And my slope is a 1, so that's just up 1 over 1 to the left and right. So you got that shape there. Last one, number 4, should have looked something like that. We had some missing numbers. We didn't have the A or the H. And so in that case, if you wanted to fill them in, it would look like that. And my center, therefore, would be 0, or not my center, my vertex would be 0, 3, which is right there. Slope is -1, so I would go down 1, right 1, down 1, left 1. Our graph would look like that upside down V there. Okay. So there are the solutions for student practice. Let's move on to another set. So you guys may notice something a little bit different about these ones. Now there's a number in front of the X as well. We kind of talked about that a little bit last time. So we're going to make a little bit a note here so that you guys will know how to handle those kinds of things. Here we go. So if there is a number in front of X, in the absolute value bars, we need to do the following things. Factor it out. Take the absolute value of it. I'll show you what I mean by that in a minute. And multiply it to the front. So the first step shouldn't be too unfamiliar to you. We did that last time. Last time when we had the AX plus B situation, right? We factored it out. Well, we kind of need to do that again here. It's just that this time we got to do a little bit more. Not only are we going to factor it out, but we're actually going to take it out of the absolute value bars completely. That way it will have the proper setup for graphing that we've been dealing with so far. So go ahead and move on. So I need to demonstrate now for you what I mean by that. All right, so we're going to take the equation here for number 1. We have a 3 there, 2x minus 6 here. And what we said we need to do if there's ever a number in front of the x, okay, we need to factor it out. So what do I mean by that? We're going to put parentheses with the 2 in the front. And what's going to go in the parentheses is what we would get if we divided the 2 out of both of those numbers inside the absolute value bar. So if I divide 2x by 2, I get 1x. And if I divide 6 by 2, I get 3. So there's that. That's the first thing we need to do. And that shouldn't look too weird or abnormal to you because we did that last lesson. So hopefully that's looking a little bit familiar. But the next thing we're going to do is we're going to separate that 2 now completely from the x minus 3. And here's what I mean by that. We're going to take the absolute value of the 2 separate from the x plus 3 there. Next, what is the absolute value of 2? It's 2, right? And then we multiply what's left. So now I'm ready to graph this, okay? As you guys can see, if you tried graphing this thing up here from the beginning, you would probably get a very wrong answer. You would think that your vertex was 6, 1, and you would think that your slope was 3. But it's not. Your vertex is actually 3, 1, not 6, 1. And your slope is not 3, but it's 6. And all of that is because that little 2 was in there. And so what we do is we factor it out, take the absolute value of it, and then multiply it to get 6, okay? So now that I have the correct equation, I want to graph it. That's the point. So here we go. Let's go ahead and graph it now. So now I can see that my vertex is 3, 1. So I'm going to go over 3, up 1. And I can see my slope is 6, so that means I'm going to go up 6 from the vertex, and then over 1. So up 6 over 1 from the vertex, up 6 over 1 from the vertex, and there we go. All right, but the graphing part's not the new thing, okay? I really want you guys to know how to rewrite this equation without that number there. Okay, so the steps are factor it out, take the absolute value of it, and multiply it to the front. So before we do any more, I want you guys to try one. Let's start off with something simple here, okay? Let's do, I think that maybe number 3 would probably be the easiest one. So why don't you guys pause the video here, and you don't need to graph it, but just rewrite it so that this negative 2 is no longer there. Using the steps I told you, factor it out, take the absolute value of it, and multiply it to the front. See what you guys get. When you unpause the video, you will see the solution. So the answer's down here at the bottom. This is what you guys should have gotten. Now let's walk you through it if you didn't get there. So step 1 would have been to factor out the 2. So if you what that means is you're going to put some parentheses. You're going to put the negative 2 in front of those parentheses. And what goes in the parentheses is what's left after you divide both of those by negative 2. So negative 2x divided by negative 2 leaves you with x. 2 divided by negative 2 leaves you with negative 1. So that's step 1. Factor it out. The next thing is to take the absolute value of that negative 2 there. So I separated the negative 2 from the x minus 1 in their own sets of absolute value bars. And I took the absolute value of negative 2. Now the absolute value of negative 2 is a positive 2. And then we multiply 2 times 2/3, which just think of that as a fraction and do top times top, bottom times bottom. And you get negative 4/3 and then absolute value of x minus 1. So now that we've got that, we're going to go ahead and graph it. So what would the vertex be for this problem? For this problem, the vertex would be this number, which is 1, opposite sign, and then this number, which isn't there, which is 0. So it'd be right there. My slope is negative 4/3, so I'm going to go down 4, and then right 3 from my vertex. Down 4, right 3, down 4, right 3. Put me right there, and our graph. Okay, so that's the basic idea there. Let's do another one really quick before we move on. Let's have you guys go ahead and do number 1. This time I want you to do the whole thing. I want you to get rid of that 3, factor it out, and multiply it to the front after you take its absolute value, and then graph it. So do the whole thing. Pause the video, and when you unpause it, you'll see the solution. Okay, so after you take out the 3, following the steps that I gave you, you guys should end up with this expression down here. Right, and here's all the math I did to get there, so I'll let you study that. But you should have ended up with 1 absolute value of x plus 3 plus 1. So my vertex in this case would be negative 3, 1. My slope is 1. So start off at negative 3, 1. And then we're going to have a slope of 1. So that's up 1 over 1 to the left and right. And there's my V shape. Okay. All right. One more thing we'll talk about before we call it a day is same problem, but now what happens when that number in front is an x? Well, the good news is nothing different than the last lesson we did. We talked about how to deal with that last time. So when that happens, we need to know how to divide fractions. Make some writing space here for myself. Go through the problem. All right. So we need to factor out that 1/3. If I divide 1/3 by 1/3, it leaves 1. So it's just going to be 1x. But now I need to divide negative 1 by 1/3. So negative 1 divided by 1/3. What would that be? It would be same, change, flip, which is going to be negative 3. By that, so minus 3 is what goes there. And then we're going to separate the 1/3 from the x minus 3 into its own little absolute value. And the absolute value of 1/3 is just 1/3, right? And so when we multiply that by the 2, we get 2. So that's how you deal with the fraction ones. But I'm going to go ahead and graph it at this point. So we're going to go to the vertex 3, 0. I'm sorry, 3, negative 1. And my slope is 2/3. So we're going to go up 2 over 3. So rise 2, run 3 from the vertex, rise 2, run 3 from the vertex. And there's our graph. Okay, so that's how you handle the fractions. And of course, we're going to let you guys try one with a fraction now. So number 2. Go ahead and pause the video and try number 2. When you're done, you'll see the solution. Okay, so here's what the equation would look like whenever you take that 1/2 out appropriately. The first thing we would do is put the parentheses with the half in the front and divide both of these numbers here by half. So if we divide half by half, we're left with 1x. And if we divide 1 by a half, we're left with 2, because 1 divided by a half is the same as 1 times 2 over 1, which is 2. And then we separate the 1/2 from the x plus 2 into their own absolute value bars there. And we take the absolute value of the half, and we're left with a half. And there's nothing in the front to multiply it with this time, so it just stays there as is. So we have 1/2 absolute value of x plus 2. There's nothing over here. There's supposed to be a number here, right? So when the k is missing, we know that's a 0. So the vertex is negative 2, 0, which is this point here. And then my slope is rise 1, run 2 to the left and right. So from the vertex, rise 1, run 2, rise 1, 1, 2, and there's my graph. Okay, so that's graphing absolute value functions. And we'll see you next time.